on confusion and background noise. As an attendee, you have a control box in the upper right-hand corner of your screen that collapses and expands by clicking the double arrows. Though you won't be able to speak, you will have the ability to ask questions by entering them in the question box. If you have a problem during the webinar, you may enter it here. I'll monitor these questions and respond to you if I'm able. Questions pertaining to the presentation may be asked at any time in the question box, but will not be addressed until the end of the program, when we have built in about 20 minutes for a discussion period. Please feel free to ask those questions as we go along, and we'll get to them after the presentation. Also, when you exit the webinar, there's a very brief survey that will pop up. We would very much appreciate your feedback on our performance. Following today's webinar, you will receive a follow-up email. This email will be sent 1 to 2 days after the presentation and will include a link to download a preliminary certificate of attendance for 1.5 hours of instruction. If there are multiple attendees at your site, please forward this link to other participants so that they can download and print the certificate with their name. Before we get started with today's program, I want to give everyone a little information about this webinar series. The goal of the Designing for Pedestrian Safety webinar series is intended to help communities address pedestrian safety issues through design and engineering solutions. Modeled after the Federal Highway Administration and PBIC's in-person training course, Designing for Pedestrian Safety, this free webinar series will cover topics ranging from sidewalk design to road diets. The next webinar in the Designing for Pedestrian Safety series is scheduled for Monday, October 5th, 2010 at 2 p.m. Eastern Time. This webinar is entitled Interchanges and Roundabouts and will be presented by Fred Ranck and Hillary Isabrands with the Federal Highway Administration Resource Center. Please visit www.walkinginfo.org/webinars to register for this webinar and future ones in the Designing for Pedestrian Safety series. The 8-part series was developed by the Pedestrian and Bicycle Information Center, a national clearinghouse of pedestrian and bicycle-related safety information and resources. We offer information and technical assistance to diverse audiences about health and safety, engineering, advocacy, education, enforcement, access, and mobility as it relates to pedestrians and bicyclists. The PBIC and today's webinar are both made possible with funding from the U.S. Department of Transportation, Federal Highway Administration. Today's session will be archived and available for download on our website at www.walkinginfo.org/webinars. In addition to these webinars, PBIC offers 4 different in-person training courses to provide technical assistance to professionals and community members in developing pedestrian safety action plans and improving conditions for walking. These courses can be found at walkinginfo.org/training. Now I'm going to turn the screen over to Michael Moule for his feature presentation, Signalized Intersections. While he's getting set up with his slide presentation, I want to take a quick poll from the audience. Please let us know how many participants are viewing this webinar at your site.
Sure. My name is Michael Moule, and I'm one of the, as Debbie had mentioned, and as you probably know if you've been seeing several of these webinars, I'm one of maybe 15 instructors for this course throughout the country. And just a bit about my background, I started my career at the Oregon Department of Transportation, working primarily in the bicycle and pedestrian program. I was focusing on pedestrian and bicycle safety issues. And one of my primary roles at that point was to make sure that every project from the state DOT had appropriate pedestrian facilities and bicycle facilities included within it. Then I became the city traffic engineer for Asheville, North Carolina, and I've been a consultant since 2002, focusing my work primarily in pedestrian and bicycle transportation issues again. And I do a lot of training courses that this webinar, of course, comes from. It's one of those courses, and do other courses also related to walking and biking transportation. I think that's enough of an introduction at this point, and I'll go ahead and get the PowerPoint up as soon as everything's ready here.
Okay. At this time, Michael, I'll go ahead and pass the presentation over to you. And to clarify, that the next webinar will be on Tuesday, October 5th, not Monday. October 5th is on a Tuesday, so we will have that next webinar on interchanges and roundabouts on Tuesday, October 5th at 2 p.m. Eastern Time. Michael, I'll go ahead and switch the presentation over to you.
Okay, you can hopefully see all of the screen now. I'm going to go ahead and continue with the PowerPoint. I should mention, as far as my introduction goes, I've just recently joined in the last couple of months Nelson Nygaard Consulting Associates, moving from Tampa, Florida now to San Francisco, where I'm working for Nelson Nygaard. And without any further delay, I'm going to go ahead and start. We're going to, obviously, as you know, we're going to talk about signalized intersections today. These are learning outcomes that we typically show for this particular webinar. We're going to think about how traffic signals don't guarantee safety. Their purpose is to assign the right-of-way. There are some safety benefits, perhaps, but we don't want to assume that signals solve everything, and that's an important element we'll talk about. We'll talk about the major conflicts for pedestrians, which are mainly concurrent turning movements with vehicles. We will talk about protected turns versus permissive turns and how protected turns improve pedestrian safety. And we'll go through a number of signal timing techniques and signal display techniques that can favor pedestrian crossings and sometimes measurably improve safety. Sometimes we think things improve safety, but research hasn't been done yet to bear that out for some of the treatments here. So we're going to continue. Many of you probably attended the geometric intersection geometry webinar that was held earlier, which covered the first 3 items on this slide that talk about. The whole slide is things that, generally speaking, improve pedestrian safety at large signalized intersections. The last 3 here are things that are specifically related to signal timing and signal placement and things like that. And we're going to talk about these 3 here in the module today. So again, as I said in the introductory notes there, traffic signals assign the right-of-way. They don't necessarily guarantee safety. It's simply a tool to regulate the flow of traffic where there's too much traffic, whether it be pedestrian traffic or vehicle traffic. There's too much traffic to manage that at an intersection without signals. We often find that signalized intersections actually have more crashes than non-signalized intersections at times, and so we don't put them in specifically to improve safety. Although, again, we can do things, we're going to talk about many things we can do to make them better for safety, at least for pedestrians. So, again, we'll see this theme throughout the webinar here today, that the turning movements are the major issue for pedestrians. If you look at this image here, on the left side of the image, you can see the right turning movements by vehicles conflict with pedestrians in the crosswalk there. And these are concurrent movements. Notice the green arrows illustrate all the movements that are sort of legal during this this particular phase of the intersection or the signal. And the right turn movement and the pedestrian movements in both directions conflict. And likewise, on the other side of the intersection, the left turn movements conflict with the pedestrians in both directions on the other side. So this is the major conflict for pedestrians of these turn movements, and we'll talk about that repeatedly throughout the webinar here. Another reason why traffic signals don't ensure protection is that pedestrians ignore the light sometimes. You know, the interesting thing about this is that people that do this do so, for the most part, quite safely. We've always said this in the course, the Design for Pedestrian Safety course, but there's been a recent study in New York City that bore this out as well, is that although it can be a source of danger, people, when they go across against the light, are even more vigilant and more careful than they might otherwise be because they know they don't have the right of way, even though technically it's illegal. People cross where it's most convenient. In this case, just a few hundred feet, if that, 50, 60 feet from a signalized intersection. It may seem safe when they're crossing, so there's no through traffic, but they don't realize there's a car coming from a turning movement at a signalized intersection that could be more dangerous than they expected. And then there's the vehicle, the driver errors and things that drivers do where traffic signals don't ensure protection. One is red light running, of course. Relatively small number as far as the percentage of pedestrian crashes at signalized intersections, but obviously, as you can imagine, they'd be very severe crashes because they typically occur at high speeds, whatever the prevailing speed of vehicles are along those streets, sometimes faster because red light runners often accelerate to get through the light. And then on the right, you see the concurrent turns that we already talked about in the earlier slides, one of the major reasons pedestrians are at danger when crossing with the light. So let's talk about pedestrian signals now and how we can provide them and where we should place them on our streets and at signalized intersections. So here's an intersection. You can see it's signalized. You can see the vehicle signals shown in the little orange circles. And the yellow circle shows where the pedestrian signal ought to be. You think about the perspective of the woman with the dog in front of you. And you can see she's looking across the street. She has to look way up to her right over the intersection to see the signal, and that can be pretty hard to identify. Plus, it doesn't give her the time, the same amount of walk and flashing don't walk time as you get with a pedestrian signal. It's even worse on a one-way street like this. The person in the picture happens to be Charlie Zagier, our pedestrian expert and researcher who does a lot of research on these issues of pedestrian safety, he walked around this intersection without even knowing that it was signalized because the signals are placed in a way that it's almost impossible now to see them when he's coming from the wrong direction, the opposite direction, I'd say, not wrong, but the opposite direction on a one-way street. There really needs to be a pedestrian signal in these kinds of environments. Another example here on the left, you can see sort of not so great pedestrian signal head placement. The signal is shown. It's like our circle's in the wrong place there. We modified these slides for the webinar. It didn't quite get perfect in this case, but the circle on the right should be circling that little signal. You can barely see an orange dot back there. And that's pretty far away, and that's the problem, that it's so far away that you can't see it. It really ought to be on the other pole or somewhere closer to the crosswalk. On the right is a much better example where the pedestrian signal is pretty much in line with the crosswalk, relatively close to the crosswalk as far as distance, both laterally and longitudinally from the pedestrian's perspective. Another challenge when we're thinking about signalized intersections is this two-step crossing. Those of you that saw the pedestrian crossings module, you might have seen the webinar on that might have seen an image where we talked about a two-stage crossing for use that's a mid-block location, or perhaps could be an intersection location. But you may remember there was a big stagger between the two halves of the crosswalk for pedestrians. If you don't have that stagger and you have two different parts of a crosswalk, in this case, that are signalized separately, it can be very confusing. You can see here on the left, there's a don't walk, the hand symbolizing don't walk, and on the right is the walking man symbolizing walk. And the pedestrians in the picture were walking with the light that was for the first half for them, and they just kept right on walking. They didn't realize the second half of the intersection of the crossing really was had a different signal for it. So that can be really confusing. We need to make sure we don't place signals in a way that people confuse like this. So when it comes to the displays, the typical, what used to be the words walk and then flashing don't walk and then steady don't walk, has been replaced, of course, for the most part. I mean, there's still some old signals out there that you can find if you look carefully, but for the most part we now have symbols, which is a good thing. Generally speaking, the symbol of the walking person symbolizing walk, the flashing don't walk symbolizing don't start. You can read this all on the sign. And the steady hand, upraised hand, that symbolizes don't walk at all. It should not be a crosswalk at all. The problem with this system is that surveys in the past have shown that about half of Americans don't fully understand it. Is there a better way that we can manage and display signals for pedestrians? So part of the problem with the old system is when the signal is flashing don't walk, the flashing hand, they're not sure if they can start. Technically, legally, you're not allowed to start during the flashing don't walk. Some pedestrians do, some don't. It can be fairly confusing for folks and even drivers for that matter. So the new display, and this is now a standard in the Manual on Uniform Traffic Control Devices, or the MUTCD for short, is to have a countdown that is displayed with the flashing hand. So that when the flashing hand is going, there's a countdown that shows how much time is left before that signal goes to solid or steady, steady hand for steady don't walk. And people figure this out. You don't calculate it in your mind. I can walk 3 feet per second. How far is that? It's like about 100 feet. Do the math in your head. We don't do that. Our brains just do it for us automatically and sort of let us know how fast we can get across the street. And we often cross at the same intersections over and over again, and so we get a feel for how long it takes to cross certain intersections as well, relative to how many seconds are left. There's great research results on the pedestrian signal. I'm presenting today from San Francisco. Much of the research was done here in San Francisco on this device, both from an operational point of view here, and then we'll talk about safety research in the next slide or two. The pedestrians understand how it works. It's just intuitive. The countdown's there. They see the number getting down towards zero. That just kind of means that people understand that it means they should be out of the intersection by the time it gets to zero. One of the concerns that people had when they put these in is that more people might start crossing during that clearance phase, which again technically is illegal to cross during the flashing don't walk, and that's true. We did find that in the research. But more important than that, we found that fewer people initiate their walk late in the clearance phase. In other words, if they see there's only a few seconds left, they don't even start trying to cross, whereas those same people might have saw the flashing and just in such a hurry they just go ahead and cross anyway and then get caught in the middle of the street before the white light changes to green for conflicting traffic. And there's almost no pedestrians are left in the crosswalk during the steady don't walk because of the count that people either don't start or they rush their walk or hurry across so they get out of the street in time. Another concern of us traffic engineers was that drivers would take a cue from the countdown and accelerate to beat the light. It turns out that, yeah, some drivers do pay attention to things like countdowns. I bicycle a lot, and I know some colleagues in my office do this as well, and I'm sure that I use the countdown as a bicyclist to help me speed up or slow down. And I've seen drivers do it as well, but the bottom line is that safety-wise, it hasn't been shown to be a problem. And the reason why is because drivers like that. And I've actually been in cars with taxi drivers and others, both with or without these countdowns. Drivers tend to accelerate towards the flashing hand anyway, because they see this flashing hand. They know that's going to change to yellow probably not too long after that. With the countdown, I've seen drivers see the countdown further away, only 3 seconds, and say, oh, I can't make that, and just slow down in advance, whereas they might have accelerated and they had to slam on their brakes if it had just been a normal flashing hand. So it turns out to not be a major problem as far as drivers using the countdown inappropriately. And from a crash reduction perspective, again, the research here in San Francisco showing about a 25% reduction in crashes after countdown signals were installed. And the amazing thing also about this research is that it actually showed some safety benefit for not just pedestrians, but also for motor vehicles, actually reduction in motor vehicle crashes with the installation of countdown signals as well. So because of the great research results of the countdown, brand new in the 2009 UTCD, they say it's 2010, boy, that seems like old news now. Well, it's not that old because even though it's 2009 manual, it only came out in January. It was adopted and official in January. And in fact, some states haven't even fully adopted it yet. The deadline is soon, but they haven't adopted the manual. So it is fairly new, and countdowns are required for new signals. There is an exception if you have a very short flashing don't walk interval of 7 seconds or less. This would be for very, very narrow streets, generally speaking. And the reason why, again, is because of the great research results we saw, reducing the pedestrian vehicle crashes and all crashes, and the behavior changes that we saw were also, for the most part, positive with the countdowns. Let's talk about push-button placement and making sure those are convenient. One of the things you'll see a trend throughout this whole module, the way I presented this whole webinar, is that if we can make things more convenient for pedestrians, we'll get better behavior by pedestrians. I hear traffic engineers that I talk to all the time. I am a traffic engineer myself. They always complain that people, whether they're drivers or pedestrians or bicyclists, aren't doing what we want them to do as traffic engineers. They aren't following the signals, they aren't doing this, aren't doing that. But then we go do things that are very inconvenient. You're going to see a few things in this next little bit that are pretty inconvenient. And you'll see that, and so a constant theme here that I'll be talking about, if we can make things more convenient in a number of different ways, then yeah, people will use the facilities you provide to them. And oftentimes that is safer to do. So the recommendations as far as push-button placement, new in the UTCD now, these are brand new requirements, or modified requirements, I should say. They should, generally speaking, be in line with the crosswalk, so it's not too far away from the continuation of the crosswalk into the sidewalk area. The buttons should be at least 10 feet apart. It makes it easier for pedestrians to distinguish there's one button for one crossing from the one for the other crossing. Generally speaking, between 1.5 and 6 feet from the curb, again, so the button's not a long way away. It should be relatively close. You push the button, and it should be very convenient to the ramp and the curb. And the button face itself parallel to the crosswalk, so you can just reach out whether you're standing like the guy shown in the picture or someone's sitting in a wheelchair. It's easy to reach. You don't have to reach around the pole and things like that. Here's an image from the MUTCD that shows all of those requirements. If you can see, that 5-foot maximum is the maximum distance that it can be away from being in line with the continuation of the crosswalk lines. They go up to the sidewalk area. The 6 feet is the maximum distance from the curb, 1.5 feet minimum. Again, same numbers I told you before, but a little bit different diagram that shows sort of the hatched area being where you can put the push buttons. So let's look at some poor push button placements. Some of these are kind of fun. At the end here, we'll see interesting items here. But the one on the left, you can see it's very inconspicuous. It's hard to find that button. Put up a sign, it makes it easier to find, but it's just not an easy place to find it. The one on the right, too far from the ramp and stuck behind that big power pole. Not easy to get to, not easy to find for the pedestrian. Behind guardrail, right? Pretty bad, right? It's hard to reach that if you're anybody's going to have a hard time reaching that. Same thing on the right with behind vegetation. You don't want it on the back of the pole. It used to be a standard in some states. other states, it was on the front of the pole, or Oregon, actually, where I used to work, went back and forth, which is why you can see on that pole on the left, there's several mounting locations. You can kind of see where the button had moved around a few times. Now we recommend that the button be, oh, sorry, one more. It's all of the above, where it's just really bad. To me, it's amazing to me that human beings can actually install a button in a place like this for other human beings to use. It just baffles me. But if you think about this a little bit and how this works, is that a lot of the challenge with this is that we have two different designers designing the roadway and then designing the signal stuff. Different people design those. It's not usually the same person. So signal designer puts a pole on the plans. Roadway designer puts the other stuff in there. They got to move things around in their construction. And that's where it really has to be dealt with, is often in construction by the installers and ultimately the responsibility of the inspector for the agency that's putting it in. So it's really the problem, part of the problem is that there's so many people involved with this process. But the bottom line is we can't just put the button on the nearest signal pole. We have to do things like what's shown on the right here, put the button oftentimes on a special pole that's just for that purpose, because it needs to be in that specific location as required by the MPCB. And again, notice in both images here, the button's near the side of the pole here on the left, or on the right again, it's on the side of that pedestal that's just for the push button. We can communicate with pedestrians in different ways as well. A new idea that's not a requirement at this point is you can put in an LED, like an elevator button that lights up when you receive the call. Yeah, this will also make our buttons last long. Instead of someone going up there and pushing the button 10 times to get the light to change, they just push it once, the light comes on. Oh, I know it received the call that I put into the signal. On the right, you can see the tactile arrow, something that's I'm not going to go into details on the accessible pedestrian signals, the audible signals for people who are blind or have low vision. But this is one feature that can help pedestrians who are blind or have low vision. And there's a lot of other features that are going to be a requirement in the future, but aren't currently a requirement right now to put in all these accessible features. But it's a nice thing to do, to provide additional information. The arrow points to where the crosswalk is, and is required to be in line with the crosswalk if it's used.
Hi, Michael. This is Davian. I'm sorry to interrupt you. We're getting some audio complaints. Is there are you using a speakerphone that we can switch to?
I can try to call along with a phone. Let me just try calling in.
Okay.
Are you there?
Yes. Yes.
Is that better?
Yeah, we can hear you great. I can hear you great now.
Okay, I hope this will work. Yeah, so we're still working on trying to get the technical issues working out here for the webinar.
All right. And I want to apologize to everyone for that. Yeah, if you want to go ahead and continue with your presentation, it seems like I can hear you a lot clearer now.
Okay.
All right.
All right, I just have to go back now. Sorry, I just hit the wrong button there. Okay, I think we were here. And I was just going to present this slide that talks about the fact that there's another new requirement. It's a fairly straightforward requirement. It just simply says the positioning of the push buttons and the legends on all the signs that are used with the push buttons need to clearly indicate which crosswalk signal is activated by each push button. It's been a continuous problem where you don't know which button to push, and new requirements make it clear that you have to, as a designer, make it clear to the pedestrian that the button that's in front of you is for a specific crosswalk, and you should know that when you walk up to it. Let's move on to other issues now, talking about signal timing and walking speeds for pedestrians. The old requirements for walking speeds were 7 seconds of steady walk, and that's the time that pedestrians are allowed to enter the crosswalk. That's a minimum requirement. Again, it's a minimum standard for that. 4 seconds is an option where you could use 4 seconds in special circumstances if you determine that 7 seconds wasn't necessary, but typically 7 seconds is the minimum. The clearance time from curb to curb at 4 feet per second is calculated simply by dividing 4 feet per second into the crosswalk length, which for a 60-foot crosswalk would be, in theory, then 15 seconds. So the absolute minimum walk plus clearance at a 60-foot crosswalk would be 15 plus 7 equals 22 seconds. So that was the old requirement. The requirements have changed now in the 2009 UTCD. Nothing's changed with the walk, the 7 seconds of walk, or the option to sometimes allow down to 4 seconds. Nothing's changed there, but the clearance time now is calculated based on a 3.5 feet per second walking speed. So that same 50-foot crosswalk would now require 17 seconds of flashing don't walk, or flashing hand clearance time
at a typical intersection, a 60-foot crosswalk. There's also another test, because what happened is that they went back and looked at the research, and new research was done and found that the 4 foot per second walking speed left about half of pedestrians in the crosswalk, about the 50th percentile for walking speed. So what was chosen then at 3.5 feet per second is about what we call the 15th percentile walking speed, which means that 15% of the pedestrians actually walk slower than that, 85% walk faster. So they said, well, we need to think about people that walk even slower than 3.5 feet per second. So they said, okay, we're going to have a new requirement that's based on 3 feet per second, and we're going to assume then that pedestrians who know they walk slow are going to start right at the beginning of the walk time. We need to calculate based on the 3 feet per second walking speed the crosswalk length plus the distance to the push button, which we're going to assume for the purpose of our little exercise here is 6 feet, which is the maximum allowable distance in the new TCD. So with that 3 feet per second walking speed, which only leaves 1 or 2 percent of pedestrians are slower than that. So it pretty much covers almost everybody. That requires then 66 feet requires 22 seconds of walk plus flashing don't walk. So again, it's the walk plus the flashing don't walk for that crosswalk length plus distance to the push button divided by 3 feet per second. So in this case, that 22 seconds is less than what we already had calculated before, 24 seconds. So we don't have to change anything. So we find that if you get to about 80 or 90 or 100 feet with your crosswalk length, this new requirement means you should add some time. And we recommend then adding that time to the walk interval to make it have more time that pedestrians are legally allowed to enter the crossing. So now let's talk about this issue of the turning pedestrians and the turning vehicles with the pedestrians crossing the street, primarily the left turn conflicts. So we find that we know that turning movements result in crashes at signalized intersections, and we find that left turning crashes with pedestrians are about 2 times as more frequent than right turning crashes. So we'll talk more about that one today. We will talk about some countermeasures for right turning crashes as well in a little bit. But we find a crash reduction factor of about 70%, not just for pedestrian crashes, but for all crashes, where we have, if we can use what we call protected left turns. And I'm going to show you in a moment what I mean by that. So permissive left turns, we had to modify the animation a little bit. There's no animation allowed in our webinar format. You wouldn't see it if I had it. So I've tried to make this work in a different way than we normally present it. So we'll see how this comes out. And this is new for me as well for you. So it's for you. So what happens with permissive left turns is that first, the only signal that comes up is the green ball, the round circular green signal, along with the walk signal at the same time, which everyone starts trying to go at the same time, the 3 drivers and the pedestrian. And the blue cars represent 2 drivers in the up or northbound, we'll call it, direction. And the red car, or the red circle, is a vehicle making a left turn. And so he yields then to, that driver yields to the oncoming traffic and then starts to turn after that traffic is passed, and you see the potential then for a crash to take place here over in the crosswalk area as that driver turns and comes into conflict with the pedestrian. Often these drivers only look for, even in nature, we look for things that are large and can threaten us. So we're in a car or a large vehicle as opposed to a pedestrian that's walking, particularly coming from the opposite direction as I showed in that image. So if we have protected left turns, in this case we're going to show a green arrow before the green ball, then this driver gets this green arrow and can make its turn into the other street. And then after that, as you turn to the other street, after that the green ball comes up along with the walk signal, and the pedestrians then can move without conflicting with any left turning drivers from that other direction. So that's the reason why that's a lot safer, not only for pedestrians, but also for motor vehicle traffic. But it does reduce the capacity. So we see engineers and designers using permissive left turns frequently, or we look at next, which is called protected and permissive left turns, where there's an option for both. Which what's going to happen here is that we're going to have a protected space at the beginning. So you see here's the green arrow. Some of the cars represented by the first red dot make the turn and clear to the other side. And then the right turning yellow now for the arrow, the left turn arrow in that direction. And then the next phase, again, is kind of back to where we saw at the beginning, which is that permissive phase where the blue cars are going north and the pedestrians heading south with this walk signal. But there's still additional cars that want to make that left turn, represented by that second red dot and they again yield to that oncoming traffic. And sometimes to get to the pedestrians, you get that same possible crash here at this location. Very popular from a capacity point of view, this protected permissive phasing, but it does reduce safety when compared to protected only phasing that I showed a moment ago. So the solution to this protected permissive left turn phasing, one thing that can be done is you can provide protected permissive phasing by default, where it operates similar to what we saw on that last slide in general, but if a pedestrian pushes the button, then it reverts to protected only, so that there's no permissive turns allowed when a pedestrian pushes the button if that left turn looks clicked with. Sorry, just noting that I had a little note coming to me. It says that the audio is much better. That's good to hear. Okay. There's another solution to that, and that's what's called the flashing yellow arrow for the left turn movement. And it's going to be a little bit hard to show because we can't animate. This little starburst around the signal means that's flashing. So you're not going to see it flash, but that's what that starburst means. So I'm going to show you some details on how this works. It reminds drivers then to yield to pedestrians and oncoming vehicles. And so you'll see how that works here. So we're going to go step by step through these phases here. So for the north and southbound movements only, we're going to start with just everything being all red. Both the arrow and the round or circular red. We're going to bring up a left turn green arrow first. We're not going to show any cars moving in this case. I'm just going to go through the phasing here. Left turn arrow comes up, allows traffic turns, in this case in both directions. It could be just one direction at a time, depending on how the signal was timed and if there were cars waiting to turn in both directions. Then it goes to a steady yellow turn arrow to terminate that green phase for the left turn. And then back to the red arrow and circular red, usually just for a moment. It's happening because it's all red, and then very briefly, then it goes to the green ball. And the big difference now between this and the typical protected permissive phase is you now have this other signal head that has this flashing yellow arrow. And just imagine that that's flashing yellow during this green ball interval, which flashing yellow generally means you're allowed to make that movement, but you have to use caution when doing so. And it has been shown to improve safety overall at signalized intersections where they use protected permissive phasing, this flashing yellow arrow. And then at the end of that green interval, you see a short, all yellows for both movements, for all the movements north and south. Yellow arrow and yellow, around yellow signal, and then back to the red arrow and red circular red. So that's how that works. It's a new treatment. It has been shown to reduce crashes for all users. I haven't seen research that shows a specific reduction for pedestrians. That's why we're not showing a crash reduction factor on this particular treatment. So let's talk about some other signal timing ideas to minimize pedestrian delay and conflict. Again, a lot of these things are things that just make things more convenient for pedestrians and therefore potentially safer as well. Just in general, using a shorter signal cycle length. This is the total amount of time that it takes the signal to cycle through all of the phases that it's going to have. Typically, they range from 60 seconds, and I've seen them up to 4 minutes. 240 seconds is ridiculously long. Think about that as a pedestrian. You have to wait for 3 to 3.5 minutes to cross the street. People don't wait that long, and that's the problem with using too long of a signal cycle. So try to use, from a pedestrian's point of view, whenever possible, the shortest signal cycle length that you can possibly use, given the other factors. So obviously there's traffic and other issues that require other elements for signal phasing. And even the pedestrian clearance interval sometimes on a big street is going to make it, you have to have a little longer signal cycle than you might want to have. You get two problems. Obviously, one I already talked about. People may cross against the signal. The other one is that it causes people to sort of stack up and crowd up on the corner. You can see in the picture here on the slide. At high-use crosswalks, we should have signals for pedestrians every cycle. So every time someone comes to the corner, the signal comes up to walk. They don't have to push a button to get the signal to change. This is important in high-use areas, downtown areas. We typically do this. Similar to that, we can set pedestrian signals to recall to walk, which means that they default or automatically change to walk when the major street is set to recall to green. So if you think about this street here, this is the major street north-south, the minor street east-west. And generally speaking, as traffic engineers, people design the intersection so that major movement is favored. So they always have a green signal unless someone comes up from the side street or wants to cross the street with the major street and pushes the button. that always defaults to green, or we call it technical terms, we call it to recall to green. And let's do the same thing for the pedestrian signal that runs parallel to that. If we're going to have the signal for vehicles recall to green, we also have the walk signal recall to walk. And that's not always done. It's an option in the PCD, but it's something, again, we can do to make things more safe for pedestrians. More convenient and therefore more safe, I would say. Now let's talk about another treatment. It's called the lead pedestrian interval. It gives people a head start to cross the street. It looks like just a normal signal to drivers. Nothing really changed unless they're very observant. They don't notice the difference. But it gives pedestrians a head start. This particular example is a somewhat unusual intersection where it's a one-way street. Comes to a T here at the Capitol Mall in Salem, Oregon. And then you can see it's a one-way street. The cross street is also one-way. So it's a double left turn. The crosswalk on the left used to be closed. I used to work in the building. It's just in the very upper left-hand corner of the image. It's the Oregon DOT, Department of Transportation building. And there's no cafeteria in that building. And across the street, on the near corner where this white car is parked, is the Revenue building. And it does have a cafeteria. So guess who was jaywalking across the street all the time? It was all those Oregon DOT engineers going back and forth to the cafeteria across the street. So the city of Salem was kind enough to open the crosswalk, which was previously closed, and allow us engineers to cross the street more readily. But to do it, they put in this LPI, this lead pedestrian interval. And this is how it works. So you can see, again, from a driver's perspective, it doesn't look unusual at all. But from the pedestrian's perspective, and the driver might notice this if they're really observant, like I said, the walk signal comes on first, about 3 seconds prior to the green interval for drivers. And the pedestrian gets a head start out into the intersection. So kind of looking at how this works and how it improves things for pedestrians. Again, it's mostly for right turns, but it also is beneficial for left turns as well. You can see here a driver wants to make a right at the same time the pedestrian wants to go across. If they both get their green and their walk at the same time, they will start moving at the same time, and there's potential for that crash to take place here, or the driver cuts off the pedestrian, as we see in many situations. That's without then the LPI. If we do have the LPI, you can see the pedestrian gets the head start. They get to start crossing earlier. They start crossing. By the time the driver gets their green, the pedestrian's already far enough out that the driver sees it, I need to yield to them, and remind they have to yield, and then they make their turn behind the pedestrian and continue on down the street. So this is a bit of a complex slide, but it's an important one to think about, and is to think about where do these extra 3 to 5 seconds of lead pedestrian interval time, where do those come from? Sometimes you think, well, it's going to take time away from cars, and sometimes that's the case depending on the situation, but a lot of times we can install these without taking any extra time away from vehicles at all, because, again, we see this situation where we have a major street and a minor street, and not that many cars oftentimes are coming across a minor street, but because it's a very long crosswalk, we might need, say, 30 seconds for a pedestrian to cross. And that 30 seconds is a long time, and will clear a lot of traffic out of each of those side streets there in each direction. It's also important to think about the fact that when you have a major street like this and a minor street, a lot of those cars in those side streets probably do want to turn. And in those situations, it's when it's really important to have the LPI, that lead pedestrian interval, to have pedestrians get that head start. So we're going to animate this slide by slide here. So first, the pedestrian gets their walk, starts crossing across the street, get partway out of the intersection, and then the green signals come on for drivers. And you can see that the first driver is going to make that right turn here. And you can see other drivers kind of going through here. You can see all the drivers starting their movements. The first driver is now turned behind the pedestrian and is continuing on. The other drivers are going through, in this case. The pedestrian is still crossing, right? It's still flashing now. It started flashing when he was about a third of the way across. The driver on the making that left turn sees the pedestrian because he's well out in the intersection now and yields while turning. And notice it's still flashing, the pedestrian's still crossing the street, and all the cars have now cleared the intersection. And then finally, now there's no cars at all anywhere around, perhaps, except the ones waiting to go through on the major street. So even though we gave the pedestrian a head start because there weren't that many cars making those turns, there was sort of dead time at the end anyway. So the idea here is to take some of that sort of dead time for motor vehicles and use that at the beginning to give pedestrians a head start. Here's an interesting scenario. A colleague of mine was at this small town in California here several years ago and actually watched these women here with their baby strollers. You might just be able to see little kid's face standing there next to the stroller. And they waited 3 signal cycles to cross the street because drivers, like the driver in the white car making the left and the driver in the white pickup making the right, would not yield to the pedestrians while they're trying to cross. 3 signal cycles. And this one has been shown to have a relatively small but important crash reduction factor of about 5% by installing this lead pedestrian interval. If we provided that here, these pedestrians could have hopefully crossed the street more readily. A few other simple ideas to minimize pedestrian conflicts here. We can do things like put in signs to remind drivers to yield to pedestrians. Here's some older variations on what we're going to see as a standard sign in a moment. Reminding drivers to yield to pedestrians when turning at signalized intersections. Notice the one in the, actually these are actually out of order as far as the names, but the one in the middle happens to be from Orlando, not Juneau, Alaska. Those two are switched as far as the names go, but notice that one's a blank out sign. You're going to see what that sign says at other times. During the screen, it says yield to pedestrians in this case, just as a reminder to remind drivers as they're making their turns to yield to pedestrians. But these are the standard signs. The one on the left is the old standard, so we won't use that one anymore. They've changed it to a graphic or symbolized sign to remind drivers to yield to pedestrians and making turns at signalized intersections. Now let's talk about restricting right turns on red. Generally speaking, in this country, right turns on red are allowed. That's not the case in most other Western countries. So right turns are allowed here, but they're not in many states. They're not in many countries, and they're not in New York City. Is not the only place that there's a blanket ban on right turns on red in the U.S. So it's something you might want to consider to improve pedestrian safety. It's not something that typically is done citywide, like I mentioned, but there may be times where it's really important to do so. And some of the reasons why you might want to do that are in situations where there's poor sight distance between vehicles and pedestrians. And the picture here is in Tampa, Florida, where I just moved from, and you can see there's a big column right there on the corner that blocks the view from the driver where the picture is being taken from. There's the driver's view, and you can see pedestrians kind of peeking around the corner here of that column. That column is supporting the convention center in Tampa, which spans over the roadway. So it has to be there, and so they put in this notion on red sign in part because of that poor sight distance. Another thing to think about is what are the pedestrian conflicts with right turns on red, and have there been actual crashes that are occurring with right turns on red? And also think about how right turns on red with pedestrians and how that compares with right turns on green with pedestrians. Again, this intersection is a good example. The crosswalk in front of us or in front of the driver here, that in theory is the one protected by banning right turns on red, right? Because when it's red, that's going to say walk, generally speaking, to cross that street. And so that's a very heavily used crosswalk to get to the convention center. As it turns out, because of the way the different hotels are and the different land uses here, the crosswalk that's sort of parallel to the direction of travel on the street, the other crosswalk is not that highly used, and that's the one that would be conflicting with the right turn on green. So again, another good reason in this case to ban the turns on red here is because there's I'd say 10 to 1 at least, the number of pedestrians crossing the crosswalk in front of us versus the one to the right there. So it's really important to ban turns on red for that reason in this location. 2 other reasons you might want to consider no turns on red would be the exclusive pedestrian phase we're going to talk about here in just a little bit, or the lead pedestrian interval that we talked about just a few moments ago, that head start for pedestrians. It's important to not allow vehicles to turn during those phases. So we can restrict turns on red in several ways. One is to do it at all times. This is an example of that, where it's just a normal sign to turn on red, just like the last picture. You can't turn on red any time. This is also allowed. You could put no turn on red when pedestrians are present. The problem with this is it's pretty difficult to enforce. It's even hard for the driver to understand. What does that mean? Does it mean anywhere in the intersection? Does it mean in the crosswalk right in front of me? Is the crosswalk to my right, my left? Which crosswalk am I looking at to determine whether there's pedestrians? And about the pedestrians that are 100 feet down the street, do they count? It's pretty hard to know, and so it's not. I don't recommend this as a good solution, but I've seen it done in a few places. It certainly is an option. We can do it by time of day. In this case, restricting the turns on red pretty much most of the day, except in the overnight hours. They allow turns on red in this example. And I don't know if you can't read the sign. It says 6 a.m. to 10 p.m. No turn on red. And then here's that same signal I showed you from Orlando, that during the red interval has a blank out sign that previously displayed yield to PEDs during green. During red, it says no turn on red. And actually, in Orlando, what they do with these signals in downtown Orlando is I've heard it's from 8 a.m. to 8 p.m. It's kind of during time of day. They bring this blank out sign up when there's a lot of pedestrians downtown Orlando, and they let drivers turn red on their own whenever they want to during the other times of the day. You could also have this work in a way that when a pedestrian pushes the button, if it's an area that has push buttons, you could bring up the no turn on red sign when a pedestrian pushes the button to crosswalk that right turn red would be conflicting with. So here's that exclusive pedestrian phase, and we sometimes call it the Barnes dance, after a famous traffic engineer named Henry Barnes, who worked in several cities, including New York City, and implemented this in a few of his cities. It's popular because it stops all traffic in all directions, and pedestrians can then cross not only in the normal crosswalks, but also diagonally, as shown here with the guy crossing through the middle of the street here. But everyone, including pedestrians, pay the price in delay. If you look here, we see the pedestrian standing on the corner waiting for traffic in one direction. You can see traffic coming from the right here, going through and making left turns. Then they wait for traffic in the other direction. The traffic, this vehicle in the white truck's green signal is on now, and he's about to go through the intersection. They wait for that traffic as well. And then finally, of course, the reward is the pedestrians can cross in any direction. So it is definitely a safety benefit to use the exclusive pedestrian stages. You see a crash reduction factor of about 34% when these have been used. But it does decrease the efficiency of the intersection, not only for drivers, but for pedestrians as well. And typically, we only recommend this being used where there are very high pedestrian volumes and many turning vehicles conflicting with those pedestrians. Otherwise, we don't use that often because of the significant delay to pedestrians and motorists. And again, when we delay pedestrians too much, we often see not so good behavior, people crossing against the lights. They don't want to wait for all that traffic to move in all those directions before they can cross. And again, it's important to have no turn on red signs. In fact, I think if I go back a slide, I guess there isn't one here, but it would be important, in my opinion, to have no turn on red sign posted at these intersections to keep drivers from turning across the crosswalks when the walk signals are on. Okay, one last item here, and then we'll turn it over to Q&A. We're going to talk about using ITS, or Intelligent Transportation Systems, to help pedestrians out a little bit. Kind of a neat solution that was done in Portland, Oregon. This intersection here, it happens to be an unsignalized intersection. They simply added a pedestrian crossing to it. Technically, that's not allowed per the MUTCD. Portland and Seattle are doing this anyway. So let's just assume that this is mid-block. We can use it somewhere else. But it doesn't really matter. Where it is doesn't matter as much as how it works. So the idea here is to help pedestrians who are slower get across the street. This signal existed for pedestrians to cross. It's a pedestrian signal. So pedestrians push the button, they would get then, when this was installed, the requirement was 4 feet per second for the walking speed. And then we get a walk signal plus however much time to cross the street that it took to cross at 4 feet per second. But there was a request by people in the area that said, we walk a little slower, we need more time to cross the street. So the city said, well, we could do that, but if we brought a slower walking speed of 3 or 3.5 feet per second, it would mean that we'd have more delay in motor vehicles every time that every time someone pushed the button. Let's try something else. And they put in these microwave sensors. You can see them up here with the circles around them. Pointing down towards the street and aiming at the crosswalk, tracking pedestrians as they cross the street. They're microwave-based sensors to help pedestrians cross. So the signal timing wasn't changed in general. The pedestrian clearance time was timed at that normal 4 feet per second for the flashing hand, the flashing don't walk. But the sensor here, as pedestrians cross the street, is a sensor, the microwave sensor tracks the people as they cross and then adds 4 seconds of crossing time if pedestrians haven't finished crossing by the time that the flashing don't walk would normally get to 0. Okay, it'll do it up to twice. It won't add any more than 8 total seconds to the crossing. So the city, wanted to see what the effect was and how often that was used. And what they found when they studied this is that the walk phase was prolonged in only about 20% of the crossing. So if they had just changed the timing to, say, a slower walking speed all the time, they would have delayed traffic all the time by a certain amount, whereas in this case, the 80% of the crossing didn't require any extra time in reality, so they didn't have to delay the traffic by all that time. So a couple of interesting things about this is that earlier I talked about the change in the requirement of the walking speed to 3.5 and then 3 feet per second as a check. And the new MUTCD does have a statement in it that allows you to do just this, what's talked about in this last set of slides, and that if you have some way to detect pedestrians and prolong the walking time, then you don't have to reduce the walking speed to 3.5 feet per second. You can leave it at 4 and then extend the time as needed for slower pedestrians, as done in this example. Another thing to think about is people often ask me, well, what happens with the countdown signal when you do this? Does it go down to 0 and then go back up to 4? And the answer is that it just continues to flash. It goes to 0 and then it blanks out. The countdown generally blanks out and the signal keeps flashing to help pedestrians get across the street. That's my understanding of how this will work, although I've never seen one installed with the countdown. That's what the technicians tell me would happen if the signal was built that way. And that's actually all of the PowerPoint that I have, and we definitely have some time here for Q&A. If there's any questions, there's a different webinar that occurred on Signalized Intersections several years ago now that has even more detail on accommodating pedestrian signalized intersections. And of course, this webinar that we're presenting today will also be archived as well. So you'll have both this webinar as an archive and this other webinar with the web address shown above here as another resource for pedestrian signals. And with that, I'll turn it back over to Devian to start asking me questions. Hopefully you've all started typing them into your chat boxes, and if not, start typing those questions in.
All right. Thank you, Michael. Now we have time for some questions. Please enter your questions into the box on your screen. Again, if we run out of time for your questions, we will attempt to answer it and get back to you after the program. All right. It looks like our first question is about a New York City study that you referenced earlier on safety for unlawful ped crossings, and they just wanted to know if you had the citation for that study. They wanted to just so they could reference it later.
Sorry, can you repeat the question again?
It was for a citation for the NYC study on safety of unlawful ped crossings. They just wanted the citation so that they could reference the study later.
Okay, I'm not going to be able to find that right now.
Okay.
I can dig it up and get that sent out. It can be sent out. I think we're going to try to answer a few other questions. You'll be able to send out questions via email or answer
Yeah.
via
So what
email,
we'll do is we can follow that up later, and we'll get back to that.
Yeah, just write that one down, Debbie, and I'll answer that later.
All right. Sounds good.
I just got emails about it in the last month. So.
Okay. The next question says, what do you think about near side rather than far side pedestrian signals?
Okay. I see what you're saying. So the question is what I think about near side versus far side pedestrian signals, and that's as far as putting the pedestrian signal on the near side versus the far side. And I think that's done certainly in some European countries. I've certainly seen that. I think that it's something that can work because it's a little bit different, and the pedestrians know when they start that they get their walk, and they can keep going until they get to the end. I don't expect that that's something that will be implemented here in the United States anytime soon. I haven't seen any research done on it. If someone were interested in trying that out here, the way to do it and to move forward trying to get that implemented in the MUTCD here would be to do a research project that looks at that, the idea of a near side pedestrian signal versus far side. I don't have any information as to whether they work better or not because I've never seen any U.S.-based research on it.
Okay. Thank you, Michael. All right, moving on to our next question. How about red, yellow, green pedestrian signals instead of the flashing don't walk sign? So I guess they're asking for your opinion on this.
Yeah, I mean, there's a lot of discussion on using red, yellow, green signals instead of the flashing don't walk. I don't expect that's something that will be changed in the near future. There's certainly been advancements in the pedestrian signal displays with the countdown. One thing that I know is being discussed and studied a little bit, though, is it kind of relates to this, and I think that sort of the reason why people want this or desire something like a red, yellow, green signal is to have the sort of clearance time be more advisory versus prohibitive. So technically right now under state laws and in the MUTCD, the flashing don't walk means don't start. You can't enter the crosswalk. And so the idea behind going red, yellow, green would be, well, sort of like with vehicles, legally you can enter in yellow as long as it depends on how it's different in each state, but generally speaking, you can legally enter in yellow if you can't stop in time to get across. And so there's a desire to have this permissive clearance interval. So instead of trying to address, but I don't think red, yellow, green pedestrian zones are going to happen. I think that traffic engineers would be too concerned about having the same color displays for different users for that to take place. But the permissive, where you would be allowed to enter during the clearance interval is something that's being discussed. In fact, it was in the draft in UTCD, the draft 2009 UTCD, it actually was proposed to change the meaning of the flashing don't walk. If it's displayed with a countdown to mean instead of meaning don't start, it means you can start as long as you get out by the time the countdown gets to 0. And many of us hope that would be included in the manual because, again, the research didn't show that kind of behavior by pedestrians was a problem. Everyone does it. I do it. Most pedestrians do it. They cross during the flashing don't walk, and then they can get across before it gets to 0. And it hasn't been shown to cause a safety problem. So it was proposed. The concern, as I understand it, from FHWA was that would mean that there would be two different meanings of the same display, sort of. I mean, the flashing hand without a countdown would still mean don't start. The flashing hand with a countdown would mean you can start as long as you get out by 0. And for that reason, it was not included in the 2009 manual. I think it's going to be a push to have that added later. The other thing that I understand is being researched is the idea, being talked about in research at least, is the idea of having a countdown without the flashing hand. In other words, you have a countdown that just displays how much time is left without the flashing hand to, again, provide that permissive clearance interval so you're legally allowed to start. So I think we'll see some movement in one of those areas by the next time the manual is reprinted, or in the next edition, which will be about 5 or 6 years from now at this point. There may be, I would suspect to see some movement potentially to allow permissive clearance interval, which is a long answer to the question, but I hope that helps.
Okay, thank you. The next question that we have, it references slide 21 of the PowerPoint presentation, and it says, often I hear communities don't want to pay the extra expense of something similar to slide 21. How do you encourage communities to take on this expense?
It's required. That's the short answer. Literally, it's now required in the manual. And I understand they don't want to go to that expense, but it's now a requirement. It's going to continue to be a requirement. People need to budget more for their signals than they have been. We've been doing a colossally bad job, and I'll go back a slide. I'll go forward a few slides to show you just how bad. I mean, this is, if you can also see my slides, I mean, this is the really poor, what we got when people were being cheap, and we shouldn't be cheap anymore. It's a requirement. They need to spend more money and to budget more money for signals because these requirements, as shown in this slide and this slide, are now in the manual, and there's really no way around it. So.
Okay. We'll move on to the next question.
And Debbie, they can still see my slides. Is that correct?
That's correct, yes.
Okay.
Yes, so if you need to go back and reference any of the slides, feel free to. The next question asks, do you recommend using signs adjacent to the ped buttons push to cross intersection street or push to cross X street?
Again, let me refer to a slide. I think that this slide is a little bit vague on the issue, but it simply says that the requirement in the manual simply says that the combination of the positioning of the push buttons and the legend on the push button signs need to clearly indicate which signal is activated by each push button. In my opinion, if we do a good job of placing push buttons as shown as we just discussed in the last question, I don't think signs are necessary, personally. And in fact, I don't think they'd be required because of the placement itself, the positioning itself, the two push buttons far from each other and proximate to their respective crosswalks would provide the information that's required by the manual, that it's clearly indicating which push buttons for which crosswalk. But if that's not the case, certainly I think it's important to have these signs in. And as we move towards accessible signals for pedestrians who are blind or have no vision, we'll be seeing audible indications of potentially the possibility of audible indications of which street you're going to cross, and or braille or other tactile surfaces that tell you which which crosswalk the push button is for.
All right. moving on to our next question. It asks, what passive PED detection technologies are available? And they go further to say, just as you referenced in the presentation, I understand that microwave PED detection products are available. Would the MUTCD allow the PED clearance interval to be terminated once no PED is detected in the crosswalk?
I'm going to say I'm not sure of the answer to that question.
Okay.
I don't know. I'd have to look at the manuals. That's another one that we can answer via email. But
okay,
yeah,
sounds good.
I'm not sure. I'm just not sure. It's something that's been discussed. I've never actually looked to see if it's in the manual or not. But by the way, I should mention that microwave is possible. Video detection has also gotten a lot better in recent years for detecting different size users, and so we can detect pedestrians differently than bicyclists and different than motorists in motor vehicles. It's not perfect, of course, but it's definitely better than it has been in the past. There's other options for detection like that.
Okay. The next question asks, in reference to PED walking speed, the PED walking speed slide, does PED clearance time include yellow and all red? If not, why not?
It's an option. There's actually a slide. We don't go into it in this module. I could take me a while, but I can probably pull this up pretty quickly. Actually, let me try. But as I'm pulling it up, I'll try to describe it. The MUTCD allows for several different scenarios with how the pedestrian clearance interval fits in with the yellow and the red. They can overlap. Theoretically, you could have the actual calculated clearance interval include the flashing don't walk and the yellow and the red separately. I'm just trying to pull up a page from ETCD here real quick. Okay, so if I can find the slide here, it's actually you can show it. See if you can find it. Probably should have yours. Gotten really big. Yeah, pedestrian signal, everything else. Here we go. Can you all see that pretty well, hopefully? Let me know you can tell me if you can see it or not.
Yeah, we're able to see that.
Okay. Full screen, a little bit bigger. Maybe not. There you go. It didn't work. Okay. So this is an image that sort of shows the options for where the flashing don't walk with the countdown can occur, and how the intervals are calculated within that. So what's pretty typical as far as actually how the display works is that we see the pedestrian change interval or the flashing itself end as the yellow starts and then the red, and that's pretty typical. It is allowed for the actual time then to be calculated to the yellow, but not through the red. If I'm looking at this correctly, I'm pretty sure that's what I understood before, is that the actual calculated time can include the yellow interval. Typically, though, in my experience, even when that's the case, it doesn't display as such. Flashing don't walk wouldn't, even though you might calculate 18 seconds for the clearance interval, and there's 3 seconds of yellow, then the actual flashing don't walk or flashing hand time would be 15 seconds, even though technically the actual clearance time goes through the yellow, and that's the time that pedestrians can get out of the crosswalk. So there's several different ways that it can be done, as you can see in this slide, this image from the manual. But generally speaking, my understanding is that it can't include there has to be at least a 3-second buffer of steady don't walk display outside of the, actually, you know what? Sorry, I was wrong about that. Let me go back. The calculated time can include 3 seconds minimum buffer interval before the red is shown for that same concurrent vehicle phase, which would then mean there would be a green interval in the other direction. So again, the time in this example, the actual calculated time includes the actual pedestrian change interval, the flashing, plus the buffer interval of 3 seconds minimum. If that makes sense. So So sorry for being a little confusing you on the first discussion on that, but the actual time is calculated. It has to end by the red, not the all red phase for vehicles, but the red that would generally be associated with the next phase signal coming up at the same time. But there has to be 3 seconds of steady hand displayed before the next vehicle phase in the other direction is displayed, whether or not the clearance interval time includes that. So it can be done in several different ways, but in theory, yes, it can include both the yellow and the all red, as shown in this image here. Sorry for the confusion on that. There were some new changes made on this. This is a brand new figure in the 2009 manual, so I forgot exactly how it works.
Okay. All right. Thank you. We're going to move on to the next question. What is the rationale to decide to install median curbs, and how does the median interfere with this travel time?
I'm not sure I fully understand the question. I think that, well, let me try to answer the question. Maybe if I don't answer it fully, the person can retype it perhaps. But as far as putting medians in a street, what I recommend on that is that if you do put a median that's usable as a refuge if someone gets caught out there, that you provide enough time for the pedestrian to cross from the one corner all the way to the far corner, not have to stop in the middle. It would be very inconvenient for a pedestrian to only get enough walk, and pedestrians don't walk to where they'd have to cross, only half a street at a time, generally speaking. It is technically allowed for the time to be done that way, that you time it so that pedestrians only get to the median, but I strongly recommend against that, except in very extreme circumstances where where the street is extremely wide, or the median is extremely wide, where it takes a long time just to walk across the median, perhaps, or in a situation where those directions of travel on that street were on different phases, so that pedestrians cross one half of the street and not have to wait for a whole another signal cycle to cross the second half. It would be very inconvenient for pedestrians to do that. But as far as putting the median in as a refuge, I don't have a problem. I think it's actually not a bad idea to have something there that in case someone gets caught and doesn't make it across, someone who's slower, someone who didn't pay attention to the signals and didn't make it across the intersection before the opposing traffic got their green. It's not a bad thing to have a refuge out there for that purpose. But again, if it's really wide, it adds a lot of time, and it can make it challenging to make the signal timing work. In unsignalized crossings, medians are hugely important, and I'm sure that was discussed in the webinar on unsignalized crossing treatment that was a few weeks ago. But at signals, it's important, but not as important as it would be at unsignalized crossing locations.
All right. We're going to move on to our next question. It references slide 60, and it says on slide 5-60, stacking pedestrians waiting are in the bike lane. Any design warning signage available?
Maybe let me go back to that here. 60. Yeah, so I don't know of any specific warning signs, and I guess to warn. I'm not sure if they want us to warn pedestrians not to step out into the street, or warn bikers that pedestrians might be in the bike lane. I mean, just as an anecdote, just yesterday I was biking through Sausalito on a ride, and literally a kid stepped right in front of me into the bike lane. He was looking the other direction at traffic. He never even looked at me. He was stepping into the bike lane, assuming it'd be safe to step there, and he was going to look for traffic after he stepped into the bike lane. He just didn't think about the fact that there were bikes going by in that space. And so that's what happens. People just, again, as I mentioned earlier, human nature is that we look for things that are more damaging to us. It's not conscious. Subconsciously, we just think about what can really hurt us, and we don't think that little white space with the bike lane is there could be a large vehicle that could hurt us. And of course, bike pedestrian crashes do happen. Pedestrians do get hurt from them, but obviously not as bad as car pedestrian crashes. But it's also, of course, very inconveniencing for bicyclists. I don't know of any specific warning signs for that. I think that the key is just trying to design your street, whether it's enough physical space for all the pedestrians to wait, or like we talked about in this module, a short enough cycle length so that pedestrians are served often enough they don't get stacked up in a way that they're sort of forced to wait in the bike lane area. So it's a challenge, but I can't think of any specific warning signs that would be useful. I know I've seen at schools we see lines painted to help crossing guards keep their kids back behind the line. We call them stand-back lines. And so it's easier for the crossing guards to stand behind this yellow line, this red line painted on the sidewalk, so they're even further from traffic while they're waiting for the crossing guard to put the stop paddle up and for traffic to stop. So I've never seen anything like that, though, for just the general pedestrian population. I think that one thing that's important to know about the METCD is that it's possible to create any sort of word message sign that you'd like. I would say it would need to be a regulatory sign, not a warning sign that simply says something like, pedestrians wait on curb or pedestrians don't wait in the street. It's reminding the pedestrians to obey what's sort of already the law, right? Because entering the crosswalk before the light changes is illegal. So it's that slippery slope of adding signs that remind people of the law. But it could theoretically be done through a custom word message sign that in 5 words or less gives you the message that you want. But I'd recommend a regulatory sign that would be black on white, not a warning sign, if you're trying to give it to pedestrians. And I can't think of anything that would work. And you could do something similar. I guess you could put a custom warning sign for bicyclists to warn of that pedestrian activity, but I think that would be the wrong solution. You probably want to deal with it from trying to keep pedestrians from stopping in that space to begin with.
Okay. We'll move on to our next question. The next question asks, what are the endpoints used to measure pedestrian crossing distance? Is it the curb, level landing at top of curb, ramp, or some other option?
Good question. I should have covered that during the PowerPoint. I'll go ahead and put that slide that talks about crossing speeds. I can remember where it is. It's generally speaking, it's and it says here on the slide that the 4 feet per second is from curb to curb. So, and obviously there's a little bit of engineering judgment on this, because if you measure, typically there's a corner radius at the corner. So if you measure, say, the length of the crosswalk from curb to curb on one side, it might be 10 feet shorter than the other side, the side that's closer to the intersection, or the street, cross street. I typically measure from the middle of the crosswalk to the middle of in the middle of the crosswalk from curb to curb. That's how I do it when I'm measuring this. I use the middle of the crosswalk and or the middle of the ramp that needs to be in the crosswalk. Generally speaking, I also like to make sure that the middle of the ramp is in the middle of the crosswalk. So for me, if I'm designing an intersection, that's the same point. Middle of the ramp, middle of the crosswalk, measure the other point on the other side. There are times, however, where you just can't fit the ramp to be right in the middle of the crosswalk that you want. So it's just an engineering judgment call. But it is curb to curb, and pick a pretty typical, logical location from as far as which point within the width of the crosswalk that would be. For that second requirement, though, I'll go to this next slide that looks at that slower walking speed of 3 feet per second, and it includes both the walk plus the clearance. Not just the clearance time, but the walk plus the clearance has to be enough time for a person walking at 3 feet per second to get from the push button to the curb on the other side. So you measure curb to curb plus the distance to the push button. You want to measure both push buttons on both sides, and you choose the longer one, obviously. Whichever one is furthest, which, again, in theory, and it's new, shouldn't be more than 6 feet, but there's going to be plenty of examples of existing intersections where we're trying to reach down the signal requirements where the push button isn't within that 6-foot requirement. So you'd have to use more. If it's 10 feet, 15 feet, that's what you'd have to use in theory. So it's curb to curb or curb to push button, one of the two.
All right, thank you.
Or both, actually. Sorry, it's both. That's not one. You don't get to choose. It's curb to curb for the 3.5 feet per second. Sorry, stay on this slide. I shouldn't show you the previous slide. 3.5 feet per second, the second bullet here, from curb to curb, or 3 feet per second from curb to push button. And you have to do both tests, actually. You have to check both to make sure your walking speed is accurate, or your signal timing, walk plus flashing, don't walk, are correct.
Okay. All right, we have time for a few more questions. The next question asks, has any of the research addressed the fact that many right-turning vehicles actually turn right before the light turns green?
I mean, I'm not aware of research addressing that specific item. It's possible there's some out there. I'm not exactly sure what you mean by the question. I mean, drivers are allowed to make right turns on red, right? So in theory, it's legal to turn right before the light turns green. So that's a legal thing to do as long as the driver is stopped. I think the bigger problem that we find today is that drivers, when they make right turns on red, don't stop first, which they're required to do. I'm not aware of research looking at that. I do know that that's a safety problem that has resulted in crashes. I've actually watched video of that taking place. And I see it happen all the time. I see drivers making right turns on red without stopping and almost hitting pedestrians, or almost hitting me when I'm crossing the street. Fortunately, I know it's coming because I've seen it before. I don't start crossing when that driver's approaching to make that right turn red and looking only in the other direction. So it is a concern. I'm not familiar with research related to it, but drivers rolling through to make right turns on red is certainly a concern. I'm not, where right turns on red are banned. I'm not aware of too many situations where certainly drivers will disobey that ban on right turns on red, but generally speaking, it is technically legal to make a right turn before the light turns green. So I don't know if to answer that.
Okay. What is the maximum horizontal reach distance to the pedestrian button?
I'm going from memory here, but I believe it's 10 inches. But that's something that you want to check the standards on that. Yeah. I can actually, see if I can find that quickly. Maybe. No, I'm not able to find it just offhand. We can try to answer that question. I'm pretty sure it's 10 inches if I recall correctly. I'd have to look it up to be sure.
Okay. Well, we can post that question. I'll post that question to the website. All right.
Sure.
The next question is the LPI effective in reducing conflicts between left-turning vehicles and PEDs that were originally heading the same direction?
It's a hard question. I don't know. You'd have to look at the research on LPIs to see if there was an actual safety benefit to that. I mean, it's a tougher question because the left turn issue with the pictures that I showed of the example in Salem was a left turn, but it's an unusual one. I mean, a typical left turn where it's two-way street. There's a lot more going on, as we talked about. There's the oncoming traffic that drivers are looking for and yielding to, and they're also supposed to go to pedestrians. And it's the thing is, a lot of times those crashes that occur on the permissive left turns occur when the pedestrian was well into the intersection, right? I mean, because they had a few seconds to start crossing while the oncoming traffic was going through, but the driver still didn't see them because of that problem. I would suspect that having an LPI would give the pedestrian a little bit more time to get out there and further establish their presence in the crosswalk. And so in theory, I would think it would improve the safety. I don't know the research that's shown that, and it might be pretty minimal because, again, just where the pedestrian is at when the driver actually starts taking that turn depends on so many factors, like the length of the crosswalk, the number of cars oncoming that the driver is using to, and all those factors. So in theory, it would give the pedestrian 3 seconds or so more time to be further out there, so probably would be better. In fact, there's times it might mean the pedestrian would be clear of the crosswalk entirely if he had an LPI, but because there's the time he crossed and his LPI and the oncoming traffic went through and the driver made the left, he's already cleared. But there's other times where he wouldn't be cleared, so it's hard to know for sure. I would think it would theoretically have a little safety benefit, but I think it'd be hard to show it in the research if there'd be much benefit. But in theory, yes.
Okay. The next question asks, does a red right arrow mean right turns are not allowed on the red right arrow? If so, doesn't that conflict with right turn on red allowed?
It depends on the state. That's the best answer I can give you. You need to look at your state laws and see what it specifically says in your state as to what a red arrow means. Sometimes some states have actually changed the law to where it means you can't make a right on red. Other states allow right turns on red in that environment. I suggest that you look up the laws in your state if you want to answer the question.
Okay. Can you discuss half signals and whether they are prohibited or just not recommended by the MUTCD?
They're prohibited by the MUTCD, and the half signal. And we have one in the PowerPoint only because it happens to illustrate something that we don't have any other examples of. But this is a half signal. In other words, it's an intersection that is otherwise, and you can just see on the right side a stop sign. And for the purpose of the course, you should probably take it out, not take it out, but just change it so you can't tell that it's an intersection. We could do that pretty easily by changing the way this picture looks. But essentially, this is an intersection that is signalized for through traffic on the major street to be stopped so pedestrians can cross. But there's no specific there's no signals for the cross street, the side street here. Technically, the MUTCD states that if you signalize the intersection, all approaches need to be signalized or something like that. I forget the exact language. So with that language in the manual, it's a shall. All approaches shall be signalized or something like that. Because of that language, it's a half signals or this kind of a signal that signalized for half the streets, but not the other half, is not allowed for that standard statement. They're certainly being used in a number of jurisdictions, and I keep finding increasing ones. Interestingly enough, there is sort of a way around it, though. I've seen where instead of having it be a complete half signal like this, I've seen situations where the signal is just left in flash most of the time, but until a pedestrian pushes the button. In Tampa, I've seen that kind of a signal where it's signalized for all approaches, but it's all flashing, and drivers from the side street would just see a red flash, which means the same thing as a stop sign. And in Tampa, the one that I've seen is only operates red, yellow, green when during school times. There's a school crossing right out there. I was just talking with a colleague, I think it's St. Louis, at the conference 2 weeks ago, and she had one very similar that worked every time a pedestrian pushed the button, and I couldn't find anything in the manual that said you can't do that. So you can essentially do the same thing as a half signal that sort of never turns green for drivers because there's no loop detection. It just stays flashing red for the drivers on the side street. So that's a way to put in the half signal without going against the manual. Leave it flashing until a pedestrian pushes the button, and then go through. Right? There may be some challenge with that. I'm not sure all traffic engineers will be comfortable with it, but I don't think there's anything that says you can't do that.
Okay, I'm going to take two more. This attendee says, I thought a ped crossing across a double left should be prohibited. When is it okay, and how do you design?
There's no requirements. There's nothing that says you can't do it. I, generally speaking, recommend against having a pedestrian cross against a double left, especially at a normal where both streets are two-way. I definitely never do it in that case. But it's not. There's nothing that prohibits that. In the example I showed of the LPI, that it's indeed a double left. It's better, in my opinion, when it's a one-way street to a one-way street like that, because there's just less complexity for the driver when they're making that movement, and it's just a much smaller street for pedestrians to cross as well. So, but again, that was why that crosswalk was previously closed, and I guess I can show that real quick. But this one right here, there it is. Crosswalk on the left was previously closed because of the double left, and they opened it. They wanted to have a better pedestrian network and make it easier for us engineers at Oregon DOT. And it's odd to have that, but it works fine in that case. So that's why they use the LPI in this example. I wouldn't recommend doing it except in extreme circumstances where there really is no other option. I can never see. I can't think of any reason why I would ever allow a pedestrian from with a double left at a normal intersection that has traffic traveling in both directions. You just need to have an arrow for that. And the issue is here is that your choices for signalizing this intersection for pedestrians, the only way to make it work for pedestrians without the LPI would be to have an exclusive pedestrian phase, essentially, because you only have two vehicle phases, through on the traffic that's making the double left, the through on the cross street, and then the double left. There's two vehicle phases, and that's it. And the only other option for making this work would be to provide an exclusive pedestrian phase for pedestrians to cross that street. And in this case, I chose not to do it that way, but to provide an LPI, which in a sense is a short through the pedestrian phase. It's the exclusive pedestrian phase for 3 to 5 seconds, right? And then vehicles can start turning.
Okay. Our last question asks, are there examples of signals timed in conjunction with public transit to provide a walk signal to pedestrians crossing the street to board public transit?
I don't know. I'm not exactly sure what the question, the mean by the question. I think that in theory, for example, it would be theoretically possible to provide some sort of priority for pedestrians trying to get to a bus. I've never seen it done. I think it would be theoretically possible. I think one of the things that I've been working on frequently in the last couple of years is this issue of pedestrian crossings in public transit. Because every bus stop is a pedestrian crossing location, whether it's designed as such or not. If a bus stops somewhere, people are going to want to cross the street there, and they're often going to want to cross the street in a hurry because the bus is coming and they want to miss it. So I think that it's not a bad idea. I've never thought about doing that, but if we're talking about sort of trying to prioritize pedestrian crossings just before the bus arrives or as the bus is arriving or something, not a bad idea, but I've never heard of it being done. It certainly would theoretically be possible for the technology and the controllers, and there's nothing in the manual that would make it so you couldn't do that. So, sure, why not? Give it a shot if it's something that you want to try in your community.
Okay. Thank you, Michael. Unfortunately, that's all the time we have today for discussion. If we did not get to your question, we will be addressing all of the submitted questions and posting them to the webinar page on our website. Once again, a recording and transcript of today's program, as well as to view a PDF copy of the slide presentation, please visit walkinginfo.org/webinars. You will also receive a follow-up email 1 to 2 days following today's presentation that will include a link to download a printable certificate for PDH hours. Finally, I want to remind you that a very brief survey will appear once the webinar has ended. Again, we very much appreciate you taking a moment to complete it. Thank you again to Michael for joining us today, and thanks to all of you for attending today's PBIC and Federal Highway Administration Designing for Pedestrian Safety webinar. Thank you and have a great day.